Hey everybody, welcome to Cassandra.Lunch 53. We've definitely done it now for more than a year, and it's great. Really happy to see such a great reaction to this over the last year. On YouTube, we've had good feedback. People are finding us out of the woodworks now, and talking about Cassandra.Lunch with a particular number. Oh, did you see Cassandra.Lunch number 10? I really like that. Or Cassandra.Lunch 52 is really cool. So great work, all of the people behind the scenes here in making this happen. Let's go ahead and start it off. As I mentioned, Cassandra.Lunch 53. Today, the main topic is how to do Cassandra ETL with Airflow and Spark. I love all of these technologies, so really looking forward to it. Arpan is a engineer at Anant, and he's a bit of experience with this technology, and also a great presenter. So looking forward to that. Co-organizers, I think we have enough co-organizers now. We don't necessarily need this, but we always need help to get new speakers. If anybody's interested in speaking, I'd love to have you. We're part of a larger community of data practitioners called Data Community DC, which is made up of several groups, which you can find out about on datacommunitydc.org. It is a nonprofit. What do we cover here? We cover everything related to Cassandra, all things like Cassandra, Cassandra protocol, getting data in, getting data out of Cassandra, how to model, how to architect. See, usually we have new people to this group. Just give a quick introduction. Sandeep, I see you, haven't seen you before. Maybe I wasn't here that particular day, but do you want to quickly say hi? Maybe he's muted or can't unmute.
Hi, Rahul.
Hey, yeah, just if you could just give us a quick introduction of who you are and how you use Cassandra, or what are you looking to get out of today's meetup?
Yes, actually, happy to able to join in this particular uh, uh, call. And currently, we use only the relational databases, and I want to actually learn the Cassandra technologies and how the ETL is done in the Cassandra world. So the reason for joining this is to learn, the
Okay.
technologies and how it is done.
Great. Yeah, there's a bunch of videos on the YouTube channel, on our YouTube channel, about how to migrate from relational to Cassandra. So definitely take a look at that. But yeah, welcome.
Yeah,
I'm here to
thank
learn
you.
too.
Sure. I'll definitely
Um,
check that YouTube channel. Yeah, thanks.
Yep. Group rules, if you have a question, you can ask it. If you have a comment, you can just give it. Depending on the speaker, they may ask you to put things in chat. Just be polite and courteous. Our company, not, we help professionals build platforms that scale, specifically with real-time data analytics platforms, such as with using Cassandra, Spark, and Kafka. We're partnered with DataStax. DataStax is also a sponsor for our meetup here. And so is GW University. And we also have some local sponsors in Chicago and DC. Our data community DC is funded also in part by organizational sponsors. As I mentioned, it's a nonprofit. Are there any announcements? Anybody looking for work? Anybody have a job to offer? Any new conferences, meetups, classes coming up? If not, well, we are always hiring data platform operators, engineers, and architects, because we do this stuff for clients, and we're always looking for people interested in growing. Our events coming up, this is every week at Wednesday, 12 Eastern. We also have a data engineers lunch every Monday, 12 Eastern. couple of topics. Next topic for Cassandra.Lunch, it's to be determined. I think it's my turn to present something, so I have to figure out what I'm going to do. Cassandra.Lunch 55, migrating Postgres to Cassandra. Hey, well, there you go. There's something really useful for you there, Sandeep. And Cassandra.Lunch 56, Spark SQL Parquet tables in DACFS. Excellent. If you want to see, there's other events on our Anant.us/events. And you can always catch up on our videos, both Cassandra.Lunch and Data Engineers Lunch on YouTube. Just look for Anant Corporation or Cassandra.Lunch and you should be able to find it. We also have Cassandra.Link, which is the most comprehensive knowledge base of Apache Cassandra, with content curated from around the world, from different companies, different authors, tools, videos, resources, you name it. And it's always getting better. With that, I'm going to go ahead and pass it off to Arpin.
Hey, everyone. Let me go ahead and share my screen. All right. Let's see. Can everyone see the slide deck? Okay, great. So as Rahul mentioned, and also just as a baseline, I'm not too particular about like questions or comments while I'm presenting. So if you have a question, you can go ahead and like speak up, or you can drop it into the chat and we can get to it at a good stopping point. Or if you have something to add, or if you know something that I didn't necessarily touch on, feel free to speak up or drop it in the chat as well. But today's topic is going to be on Cassandra ETL with Airflow and Spark. And we're going to cover how you can run like a basic Cassandra ETL process with Airflow and Spark. This is kind of an introduction to get started, but it opens up a road to showing you how you can do more complex Cassandra ETL pipelines and then integrate other tools into that. So as Rahul mentioned, we also use Kafka. So if you haven't seen it before, but our repo Cassandra.Realtime on GitHub, we use Kafka and Spark for streaming and stream jobs with Cassandra, Astra specifically. Yeah, so there's a lot of room to further expand on what we're doing today. So if you're not familiar with what Airflow is, it's a tool for scheduling and automating workflows or tasks. It's good for automating repeated processes. So that's where ETL kind of falls in. So common ETL tasks. Also, you could do repeatable machine learning model training. Generally, workflows are written in Python, and you can define different dependencies based on different sections of workflows. And workflows are DAGs, so directed acyclic graphs of tasks. And we'll take a look at the DAG we set up for this demo. And then with Airflow, the important thing is that you can schedule your workflows so you can have them be running on a cron-like syntax basis, or with frequency tags like @daily or @hourly or @weekly, something like that. Very simple, very easy to use. Or you can use Airflow's UI and manually run your DAGs. And we'll be doing that specifically in our demo. And then you can also monitor your tasks and collect and view logs per task in your DAG. So you can do a lot of drill down analysis if something breaks or doesn't complete. And if you're not familiar with Spark, Spark's a unified analytics engine for large scale data processing. So generally, if you're using Cassandra, you're at that point where you have large scale data and you need to do large scale data processing. We'll be using mainly the data frame library for Spark for what we're doing today. But again, as I mentioned, if we want to expand on what we're doing today to include different functionalities to create a more complex Cassandra ETL pipeline, we could potentially use the streaming library like we do in Cassandra.Realtime, or potentially machine learning. And then you can also run Spark on a bunch of different containers, but we'll be just running it in standalone cluster mode with one worker. So actually, before I move forward, let me open up my chat just so we have it. Great. So I will send actually the the repo that I have that we'll be using. But essentially what we're doing today, the demo that I've set up is everything can be done within your browser, right? So we're going to be using DataStax Astra. If you haven't ever used it before, it's essentially a serverless Cassandra database in the cloud that you can get $25 worth of credits for free. So it's essentially a free Cassandra playable database if you're not using it in any sort of production setting. But for our purposes, like we won't even touch like maybe not even $1 worth of credits used. And so we'll be using that. Oh yeah, so Rahul said once you sign up, they just keep giving you credits. He got 200 last week. But yeah, and then we'll set up Airflow and Spark, and we'll be using Gitpod as our IDE / VM. And then we're going to show you how to connect Airflow and Spark, and then how we can then connect that with Astra. And then we'll trigger the DAG with PySpark jobs via Airflow UI. So the reason I used PySpark versus Scala, which I generally use, it's just so that we don't have to, when you go through this walkthrough, it limits the steps that you need to do, right? So if you're using something like Scala or Java, you got to build it and compile it into a jar and then pass that through, versus PySpark, you can just have your Python file and do that. So it's just easier steps just to learn the process. But if you're interested in how you can still run like the PySpark or run a Spark job through Airflow using a jar versus a Python file, you can check out our data engineers lunch that I gave on Airflow and Spark on our YouTube channel, youtube.com/AnantCorp. And then we're just going to confirm the data in Astra once we've done our basic ETL flow. So yeah, let's go ahead and get started. So what I'll do first is send you in the chat the repo link. So if you want to follow along, you can. So I've already done a couple things just to speed it up. So I've already run this setup.sh, which essentially just pip installs Airflow, initializes the database, creates a user, starts the web server, which we can see here, and then also starts the scheduler. And what we'll be doing is, let me find Gitpod. So if we look at our spark dag.py, essentially we're going to have two jobs. And so if you saw my previous webinar on Airflow and Spark, you notice that in this DAG, we're using the bash operator versus in the Airflow and Spark, we use the Spark submit operator. So because we're talking to Cassandra, we need to use the Spark Cassandra connector that DataStax builds, right? And so because the most recent version of Spark is 3.1, the Spark bash operator that we used previously, it runs it with 3.1, and the current 3.0.1 version of the Spark Cassandra connector does not work with Spark 3.1. I believe they are working on the Spark Cassandra connector 3.1 based on their repo. But for our purposes, we're just going to be using Spark 3.01 and the 3.0 Spark Cassandra connector. And I've already given you Spark, so all you need to do is just press and click on the Gitpod button on the repo, and it pulls it up once it builds. But essentially what we're doing here is we're going to run two jobs. The first job is going to be a load and write job. So what that's going to do is it's going to, we'll take a look at the actual Python file, but it'll pick up 100,000 rows from a CSV file and then write that into Cassandra into one table. And so what we do with that, we Spark submit, and then we also have a packages where we pass in the Spark Cassandra connector. And then we have a properties file, which we need for Astra, which has like our client ID, client secret, the path to the bundle, and then the path to the file that we're passing in. So for the first job, it's extract and load Python or .py. And then the second job is the ETL job. So what we'll do with that job is we'll take the data that we imported from the first job, do some transformations, and then write it into another table. And essentially it's the same exact process. It's we just change the file path of the exact Python file / job file that we're running. So in the extract and load py, essentially, as I mentioned, we're just going to load a CSV that we have here. We are going to select certain items from that CSV, and then we're going to take our key space that we have from our properties file that we'll set in a minute, and then we'll write that into one of the tables. And then for the second job, we'll then take that, we will then take that data, we'll do some transformations, we'll do some calculations. So the first table has a first day and a last day of that someone's worked at a specific, at the company, the quote unquote company. And so the second table is calculating the duration in days that that person worked. So it would take the absolute value of the date difference between the first day and last day. And then we're going to write that into a second table called days worked. So if we expand on this, we could potentially like bring in Kafka, right? So granted, this is like older employees, but say if this is newer employees that are logging time every day, or something that needs to happen like on a monthly basis, you can schedule this for a monthly, you can schedule this DAG for a monthly process. So you can essentially just turn it on and just have it happen in the background. But again, this is just like a basic introduction. And even at this event or Cassandra.Lunch, we might build a more complex pipeline just to show you how it can be done. But yeah, let's go ahead and get started. We'll need to create those tables in Astra. I have the setup.cql file in here. Oh, actually, before I get to that, let me talk about the differences between the Spark submit operator and the bash operator. So in this Airflow and Spark, as I mentioned, if we look at the DAG, you see it's a little bit different, right? So we have Spark submit operator versus the bash operator. So we don't need to have like the actual like bash command that we use to run a Spark job, versus we just give it the application and then we give it a task ID, but we could also give it like a properties or a conf file equals and then the path to the conf file. Yeah, so I'm just going to go ahead and copy and paste this into the CQL stage terminal in Astra, and then I'm just going to confirm that our tables are there, and they are. So what we are going to do now is go back to Gitpod, and we are going to open a new terminal, and then we are going to have to make a directory so that way Airflow picks up our new DAG. We're going to name it Airflow DAGs, and then we're going to move Spark DAG to that directory. So it'll take a couple seconds or so before it gets picked up, but in the meantime, let's go ahead and get our Spark started. So we are going to cd into Spark, start master. And then once it starts, we'll just go ahead and open up the UI 8081. While that loads, we'll just go ahead and get our workers as well. And then just give this a refresh, get our master URL, and then paste it in so the master or the worker knows what the master URL is. And we just give this a quick refresh, and now we see our worker. So now, moving back, let's go ahead and just check if our DAG came through yet. Okay, hasn't come through yet. So let's go ahead and set up our properties config file. Open up a new tab. So I'm just going to vim properties.conf. And so what you would do here is you would just copy and paste in your specific credentials. So for me, my Spark master, that. And remember, for conf files, keep one white space between the property name and then the value. So our path for the cloud path, it's just the name of your database. So mine's just called demo. And then so Astra implemented tokens recently. So instead of having a username and a password, you would need to create a token. I have these copied down. I'm just going to paste them, but it's very simple. The instructions are in the repo. And if I just copy and paste this in, and then database name is demo, key space name is test. And I noticed that there's actually need to make an update here. Apologies. And our database name again, demo. And then that should be it, but I'm just going to do a quick double check, make sure everything's good. Yep, so we're just going to close out of this. And then we're also going to drag and drop our Secure Connect bundle, which is essentially our auth packet to talk to Astra. So I'm just going to rename this. There we go. So now if we hopefully refresh this, we should see 27. It hasn't happened yet. Why is there an error? Let's see. Oh, I know why. Okay, so I'm just going to do GP open, Airflow, DAGs, Spark, because I renamed it and I need to update this. So copy, paste. Right. And that should hopefully get imported in. Save. Load on right job, ETL job, yep. This will load for me. Load and write job is not defined. Okay, so what happened here? Load and write. Oh, that's why. Apologies. I will update this in the code as well. That was an oversight. Hopefully this works. Give this a refresh. All right, and while we wait on that, let's go ahead and set up the connection to Spark. So we're going to go into the admin connection section, and we're going to go down to Spark default. So currently, I think the master URL is set to yarn, but we need to update that to our specific master URL. It says host and port. You don't really necessarily need to move this port address down to port. You can just leave it as is. So we're just going to go ahead and save that. If we go back to DAGs, hopefully this is in 27. It is great. So let's go down to example Cassandra ETL. So if we look at this in the tree view, but if we look in the graph view, we now see our jobs. Because we have those caret, we say run this job first and then run this job next. And if we look at the code, we'll see that the code comes through as we moved it into the Airflow DAGs folder. So yeah, let's go ahead and get started here. Let's turn this on. Let's go ahead and hit run. And we hit trigger and we go into the graph view, which is my personal easier view to look at. And we'll just give it a little bit of time. Just make sure we're not missing any steps here. Set up Airflow. Yep. Cool. All right. Light green means it's running. Dark green means it was a success. and then hopefully we'll see it turn dark green. And again, it might just take a couple seconds because the CSV file that we're using is 100,000 rows. This is just a basic, again, as I mentioned, a basic ETL process we can set up and manage with Airflow and Spark. If we wanted to, we could set schedules on this. So have maybe an Airflow process that only runs the second task on a schedule. So it happens every week, every month, et cetera, et cetera, et cetera. So if we look into here, so while the first one completed, so if we look into the logs, we'll be able to see, so it downloaded the Spark Cassandra connector. And if we scroll down, we should be able to see when it connected to Cassandra. Yep, here it is, connected to Cassandra cluster. And then we start seeing tasks. And then once it completes, it does the shutdown hook because we do spark.stop. And then if we go back into the tree view, or graph view, apologies, we see that the second job also completed. So now if we go back into Astro and we do a select count from the first table, which is previous employees, we should get back 100,000, and we do. So now if we look at select count days worked, which is the table that we wrote to with our transform data, and this should also get us back 100,000, and it does. So now if we want to do a little bit extra, we'll do where job title equals dentist. Oh, no, I don't want count, I want all. Back. Select all from, and we see that these have the days worked. So this is a calculated value that we took from the first table. So if we just find a nice whole number, so Eden Uden is 60. So now if we do that same query, but instead change the table to previous employees, and we run this, and then if we look for Eden Uden again, should be towards the top as well. Here he is, and Eden Uden was 60. So if we look at 2000, January 9th, and then 2000, March 9th. So it's about 2 months, 60 days. So we know that our code was able to extract data from the first table, do some transformations, and then write it into a new table. And we were able to do that and trigger it via Airflow. Again, using the bash operator, but once the Spark Cassandra connector catches up to 3.1 and Spark 3.1, because again, as I mentioned, Spark or Airflow's Spark bash operator or Spark submit operator runs it via 3.1. So once all the 3.1 matches 3.1, we'll just be able to use the Spark submit operator. But currently, we had to pivot and use Spark 3.01 and use the bash operator. But hopefully, by the time we expand on this specific or this concept of Cassandra ETL and Airflow and Spark, we'll just be able to use the Airflow's Spark submit operator. But yeah, that wraps up the basic demo for this. Anyone have any questions or comments?
No, this is great. So in your use of Airflow, I'm just kind of trying to wrap my mind around. So in the pod, which is basically a container that Git pod is running for you, you have Airflow and you have Spark master and you have Spark worker right now.
Mhm.
And then Astra is running elsewhere.
Correct.
Okay. So when Airflow is running a DAG, so basically it spawns how does it spawn new jobs? Is it running like a Python thread, or like I know you're using a bash operator? Okay.
Yeah, it runs a Spark submit command. Versus, so like this is the bash operator, but if you use the Spark submit operator, I believe it uses PySpark submit.
Mhm.
But generally, it just pulls in what's from the DAG. So it pulled in packages, pulled in properties files. I don't have the exact log from the Airflow and Spark last week, which used the Spark submit operator.
Mhm.
But when I was trying it out previously, trying to get this demo to work with the Spark submit operator, I saw it being used as Spark 3.1 point X, whichever one it was. So I think it spins up a process to run either PySpark, because you have to download or you have to pip install the
Yep.
Spark submit operator, and I have that in my setup.sh. Pull it up real quick. Right here. So potentially this is where that Spark/PySpark submit process happens
Mhm.
when you use the Spark submit operator.
Yeah, I mean, you could probably have like a requirements at txt for if you needed other providers. So when you go, can you go back to your UI and when you define the DAG, or at least when you start to, yeah, so like above, I think you have to go up one more. Just go all the way to the list of DAGs.
Okay.
Okay, yeah, so this, if you click on Cassandra ETL, and then so how does it know that your Spark job is done? Is it waiting for the bash to be done and saying, okay, done? Because Spark submit, basically you run the job and it just runs, and like you exit out of the Spark submit, you don't necessarily have to wait for it. Okay.
Yeah, so I think once the bash completes, has a return 0, and then
yeah. Okay, I see it. So it is kind of following any spawn. I guess, does it look under the hood to see if there are any other spawn processes and make sure that those are done?
I'm not entirely sure, but that might be something you could potentially set with your dependencies. So potentially have some kind of conditionals to affect it. Because I think if the first job doesn't complete correctly, it won't run the second one because of the dependency downstream we have set. But we can trigger a single one. So like if I want to run only the second job, I can, but I require it. You need the
Output of the
slash, yeah.
Can you go to your code for the run, I guess, load it? Let's take a look at both the load and write job and then the ETL job. Yeah, these are your Spark jobs.
Correct.
Okay, but you're not using Spark to run them. You're using the bash operator. So the bash operator, are you just typing in like a basic command, or do you have a shell file that you give it?
It's just a basic command.
Oh, so you configured that inside the user interface, not as like a bash script that is being run by Airflow. Okay, I got it.
Yeah, because versus the Spark submit operator, I think it takes these parameters and it has a templated job. And so it takes whatever values you have here and inserts that into those specific sections of the Spark submit.
Yeah, and that's what I was really wondering at, is what we're losing. So what I would expect from a Spark submit operator is that it uses Spark APIs to see if a job or an application is done or not, for example.
Perhaps, yeah.
right? Versus in Bash, you're like, you really don't have that visibility. You're just saying, hey, is this thing done or not,
Mhm.
right? Okay, cool. Looks sweet. Does anybody else have any questions? No? Great. Awesome. Well, thanks. Appreciate you getting all of this integrated. This is great. Learning, especially kind of using Spark with Astra with Airflow. Always, cloud stuff is always easier than it is. Oh, it's on the cloud. It should be easy, right? And then you get into it and you're like, okay, it's really not that easy. So it's great to have that code up there. Excellent. Yeah, I've been playing with Airflow on Kubernetes, and there's a legacy / older version, and there's new ones, and I think the way it does all of its tasks is it wraps it in a container, essentially, and it runs the container, and the container either is running or it's not, right? And so there's a type of a job in Kubernetes, or there's a container or a pod in Kubernetes called job or scheduled job, and I think it just wraps that. So it doesn't necessarily need the its own internal scheduler. It just kind of leverages. I have to double check on that, but I think that's what's happening. But very cool, awesome. Well, if there aren't any questions, we can talk about general Cassandra. Any questions about Cassandra, or anybody have a story about Cassandra?
I have a question about what you were just saying with Kubernetes. So would that then take the place of what Airflow is doing here? Like if you just have that scheduled pod job. So if you're using, you probably wouldn't be using Airflow with Kubernetes if you had a Kubernetes kind of deployment.
So yeah, so Kubernetes pods and jobs, pod jobs or scheduled jobs or cron jobs, whatever, there's a few different types, are just a fancy way of doing a cron job. But a cron job, like a scheduled job, or like just a regular job in Kubernetes, it's not that different from just running it by yourself. So Kubernetes just runs it for you, but you still have to like coordinate it, right? Mm-hmm. And what Airflow does is it manages the dependencies of what has to happen first, what has to happen next. If there's many parallel things that can happen before it culminates in like one thing, right? That is the graph of tasks. That's the directed acyclic graph of tasks. That's what's called a DAG. Spark has its own internal DAG, and a directed acyclic graph of tasks is not what Kubernetes is doing, right? It's just you give it something and it'll do it, and you can kind of rig it to say, wait until this is done, and then after that, in the next hour, run this thing. So
okay,
yeah, so like you don't have that intelligence of like, what do I have to do overall? Right, it's like a developer versus a project manager. Airflow is like a project manager. It has visibility on what everything is going. It has visibility in what is going on and what is dependent on what is going on. So it doesn't start something too early or doesn't start something too late.
So it gives you a little more control about when things start or stop or dependencies.
Well, I think it's semantics. You actually lose control of you running it, but it gives you control over the sequencing of it,
mm-hmm.
right? It gives you manageability that you didn't have before, which is what you want. So Airflow is not the only game in town. I mean, there's another in the Kubernetes world. So Airflow can work with anything. You don't have to have Kubernetes. Airflow can run on on your computer or whatever. The new one can use Kubernetes. It doesn't have to. Okay, but there's another tool called Argo, which I just kind of started playing with a couple of weeks ago. Argo has a continuous, delivery pipeline for Kubernetes, but they also have a data pipeline manager where you can similarly see visually this container runs, and after that's done, then run this container, where you can have like a parallel view of, 3 sequences of containers all culminating with, okay, after these 3 sequences of containers are all executed, then go and execute this one. And that runs on Kubernetes. That's doing everything that Airflow can do, but you don't necessarily need to write an Airflow like Python thing. You just have a container, and it just manages. And you can write the container in anything. It's similar to Airflow saying, well, as long as you can run it in Bash, I'll run it for you. Argo basically says, as long as it's a container that runs on Kubernetes, I can run it for you. And I'll wait for a definition, then I'll run the next one. And so in that respect, like Airflow and Argo, they do the same thing, but there's a little bit of overlap where Airflow and Argo do it on Kubernetes, where Argo is just 100% Kubernetes. Argo is 100% Kubernetes. Airflow is anywhere you want plus Kubernetes. Cool. Awesome. Any other questions? All right, seeing none, let's take off early. I'll give you back 14 minutes of your time. Have a wonderful rest of the day, the week, and we'll see you next time, 12 Eastern on Wednesday. Take care. Bye-bye.
Thank you.